Okay, so first question, which is maximum number of pairs in the array. So it basically says you have to discard duplicate pairs and count unique pairs. So for example, in this problem, in this sample test case, 1, 1 will get discarded, 2, 2 will get discarded, 3, 3 will get discarded. So 3 pairs will be gone. And only additional thing that will remain is this 2. So I believe everyone solved this problem. This was just an easy version. So just to keep the discussion short and quick, what are the approaches you use to solve this problem? Okay, people who solve this problem, yeah. So map was one possible solution. So if we use a map, we are counting frequency, map or dictionary, yes. We are counting frequency of every element. So basically this will give you 1 is occurring 2 times, 3 is occurring 2 times, 2 is occurring 3 times. So your map will be built 1 is occurring 2 times, 2 is occurring 2 times, 3 is occurring, sorry, 1 was 2, 2 was 3, and 3 was 2. Okay, so after you build a map, frequency map, what you essentially do, imagine, I'm just tweaking this. If 1 occurred 4 times, 3 occurred 9 times, and we had to count how many pairs get cancelled. So there are 2 things that we are counting about. How many pairs get formed and how many elements will be left out. Now, if we loop over every key value pair, yeah, so basically you have to divide value by 2, because if it is 4, we know it will give 2 pairs, and left out values, of course, you have to take plus is equal to value mod 2. So this is key value pair that we are using. So eventually, like, we had to return an array of these 2 elements. Okay, so yeah, one was map-based solution. Manisha tried, and Manisha used sort and compare solution. That will also work. So if you sort, similar values will come together. And what you essentially need to do is you need to compare to adjacent values. So if we sort this becomes 1, 1, 2, 2, 2, and 3, 3. So it becomes 1, 1, 2, 2, 2, and 3, 3. Yep. So now if you look at this 1, 1 gets cancelled. So if you find a pair, you just increment the pair. If you find a single value which does not match next value, you just count that one. So here, if you see, this is a pair, so we will increment pair. This is a pair, we will increment a pair. 2 does not match 3, so we will increment leftover value. And then we will start from here. This is a pair, so we just increment pair. So 3 pairs and 1 leftover values. Yeah, so both solutions are valid. And since this was a kind of easy problem, even kind of a brute force would work. So whatever simplest solution comes to our mind, just go and implement it.
Actually, constraints are very less. Only 100 items are there in the list in the array.
Yeah. So even if you do brute force with 2 nested loops,
Yes.
that would also work. Yes. So basically, to count the frequency, even if you use brute force, that's what. Yeah. For every item, you just do the count of it, which map is doing faster. So brute force will get accepted. But I hope nobody implemented brute force.
I did sort and compare.
Okay, sort and compare.
I think it's brute force only.
No, it's not brute force. Sorting brings it in n log n time, you get sorted. And then you just do a linear scan. So it is n log n plus n.
Okay, then.
Yeah, it's fine. I mean, it's brute force would be to pure n square. For every element, you are just looping over entire array and you're counting the frequency, right?
Okay.
Yeah. So this will be n square. This solution would be n log n plus n. This solution, depending on which map you are using, either it will be n log n plus n, because we are looping over every key value pair, or it will be n into n plus n. Basically, if you are using a hash map where you can directly jump to the index, like, then the complexity of insertion and check becomes 1. Okay, now since it was a frequency counting problem, we have done a problem in binary search where we use binary search on a sorted array to count the frequency, which we find first occurrence index of an element and second occurrence index of an element. So for every element, you would go and for every unique element in the array, you would go and do a binary search after sorting it. So then it is like sort and binary search for frequency count. That means for every unique element, you will be doing a log and search. That was one more option. Okay, so that is our problem number 1 from today's contest. Let's move on to the next problem.